Hello students, today we'll see branch instruction. Hello student, today we'll see branch instruction. The PC target underscore address, BNC target underscore address, BN target underscore address, BNN target underscore address, BNOV target underscore address. What is mean by this instruction? What is mean by target address? We'll see one by one. PC stands for branch if carry. If you are doing some addition, arithmetic operations, and carry generate, so if the carry generate, then move to target address. Target address, it may be label or it may be address. So if any carry generate or borrow generate, it will check the condition. If carry generate, then move to your target address. Next, branch if not carry. If carry is not generate, then branch to target address. Then branch if negative. If the answer comes negative, then moves to target address. If branch if not negative, then move to target address. This branch if not overflow, when you're counting something from 0 to 10, and if the counter is get full and it reach to 10, then overflow flag will raise. We have already seen in status register, the overflow flag will raise. So if overflow is not happen, then move to target address. Otherwise, stay on the same instruction. So here I have given one sample program, C underscore RG. This I assigned for the carry. To look a carry is generated. If the carry is generated, it will set automatically your status register flag, carry flag. But if I want to know that the carry is generated, then carry will you have to store in one of the memory location. So I assign or set. You can use set or equate to memory location or memory address. Move LW 0 cross 0. So you are moving 0 literal value into WREG register. Then move WFC underscore RG means what? The move WREG register value into file register. The file register is name is C register, C underscore register. Then add LW 0 cross F6. This is your literal value. Literal value is add into WREG register. C is clear, WREG is having F6. Now this instruction, what it say? Branch if not carry. This if not carry to where? To over 1. Branch if not carry, then over 1. Obviously here carry is not generated, then it jumps to over 1. Here in ADLW 0 cross 98. Now earlier WREG register is having what value? This F6. Now this 98 is added into F6. So if the carry is not generated, then branch if not carry to over. So add one more instruction, otherwise it will moves to or it will ends over here. Here end we have to write. If carry is not generated, then it will moves to end. Otherwise, branch if not carry, then it moves to here over to. It add one more thing, one more number. So keep on increasing. Then if carry is not generated, then moves to over to. If carry is generated, here F6 plus 98 will comes it comes here 98 plus F6 gives you 18 E. So here 1 is a carry. This carry will it will check the it will check the answer in WREG register. So if you find the 1 is there, then increment your REG. That means your 1 will goes to CREG, C underscore RG. If carry is not generated, then it will jumps to this and add one more number. But here in this addition we are having one carry is generated, so it will move out of this instruction, increment the C underscore RG, which is a file. That's why it's written as a file. Then branch if not 0, branch if 0, branch if overflow, unconditional branch, call. Okay, these instructions are short jump. Short jump means what? You have address location from plus 128 to minus 127. If you want to jump beyond this value, you have to use call with go to. Once again, these branch instruction have limitation. It will branch up to the address plus 128 to minus 27. But if you want to go beyond minus 127 or plus 128, you have to use call instruction. It gives you 2096 up to with the use go to over. Here I have taken one example. Counter I have set as value. If I'll set 0 cross 10, then move LW literal value into WREG register. Now this 5 will set into the memory location which is labeled with the counter. Then empty your W with placing 0 as a literal value. Then ADD-LW 0 cross 7, that means you are adding 7 into 0. Decrement counter. Now this instruction is decrement. This instruction used for decrement. It decrement only one digit. So earlier counter is having value is 5. After this instruction counter will be 4. Now if decrement, if branch if not 0 to over, then it adds 7 plus 7, then again it will decrement, it comes 3, then 7, like that it is adding here 7 almost 5 times. It starts from 0 0 7 4, again 7, 3 count, again 2 7, again 1 7, again 0 7. So it will add 7 how many times? It adds 7 up to counter 5 and store the result into the WR register. If it is not, if it is 0, then it will goes to end instruction. If the counter value is goes to, now counter value goes to 0, then it will moves from your routine subroutines and moves to end. Okay. Okay. Next, set F trace B, move WF port B, sub LW099, branch if 0, exit, otherwise branch unconditionally. What is mean by it? Set F means what? You are, this is treating as a input, and the value, whatever the value of this trace B, see trace B, port B is register of SFRs of your port. The each port has 3 registers: trace B, trace, port and latch. So to set a condition whether it is input or output, we have to use trace instruction, and if you want to send any data through the port, it consider it, we have to take as a port A, port B, port C, port D, port E. If you want to latch any data, use LATD. So before you want to send any data through the port, it must be latch on the port. So here set F, you are giving condition set and clear. There are 2 instructions. Clear means 0 0 and set means you are sending 1 1. That means you are assigning this port as a input port. Then move WF, that whatever the set data you are consider sent through the port, that means it ports get realize that it is input. Now subtract LW, the W is having some 0 0 value, and subtract 99. If the value is 0, branch if 0, then exit. Otherwise, if it is not 0, then it will move to back without any condition. This is for unconditional. So it will move continuously up to the 0. It will continuously subtract 99. Thank you, student.